Classic Electric is a licensed and insured electrical contractor. Welcome back to the channel. In today's video, we're going to be upgrading this old 100 amp service to 200 amps. We're going to be answering specific questions that I've seen in the comments. Let's get to it. So the one violation we see here right away is this is the main breaker, and so it's in the down position when it's on. That right there is a code violation. I'll post that code section you see on the screen. Now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is a Murray load center, probably 1980s, I'm imagining. Look, the cover comes right off. Let's see. But obviously you can't put in a square D home line circuit breaker in a Murray panel. That's a violation. 110 TAC 3, examination, identification, installation, use, and listing product certification of equipment. 110 TAC 3B, installation and use. Equipment that is listed, labeled, or both shall be installed and used in accordance with any of the instructions included in the listing or labeling. This looks like it's something else. Maybe that's a Siemens, maybe that's okay. I believe this is old school Murray. This is a GE. This is a GE, and this is the GE. So you always want to make sure when you're putting breakers into your panel that they match the manufacturer of the panel. Otherwise, it's not going to sit properly on the bus bar, and you could have some problems. So they've upgraded the meter, but when I say meter, I meant the enclosure. You see how it's buried into the siding right here? The new 200 amp meter is much bigger than this one. And so what we're going to do is we're going to put the 200 amp meter right over this opening and make it watertight up on the top. I don't have any PVC board today because I didn't think it was necessary, because the cutout here doesn't have J channel like some of the other ones we have, where the new meter will not cover that up. So we're going to go right over this opening once we get it done. Now, as you can see, the riser is pretty high and long. That's where it's got to be. It's got to be above the window. I don't think it necessarily has to be that high, but we're going to put it back exactly the way it was. And as you can see there, there's the service head and the weather head, or the service point I should say, and then this overhead goes right to this pole right out on the street. Okay, so as you can see, I got everything disconnected now. Pretty easy here. These cables, they come through the ceiling. We're going to do the same thing. I might have to get some blocks here to build this out because of the depth. I didn't bring any 2x4s with me. That's a shame. So these are the main circuits. Obviously this was added later, this was added later, and this was added later, but these up here, I could just tell that these are the original with the home. And it's not a huge house, but I think we're gonna go up a little higher and bring them out a little higher. This is still gonna be a surface mounted panel, but we gotta build this out a little bit with some 2x4s. Right, so here, this is called a 2-inch hub. We call this a hub. It sits on top of the meter for the overhead service, which is what we have right here. And these are irreversible screws. If you don't know what those are, they look like this. If you see the edge right there, once they go in, you can't reverse them because there's nowhere to put your screwdriver. I mean, I guess you can take them out with a pair of pliers, but that's not what they're designed for. They're designed to go in and not come out. So when you're putting them, when you're attaching the hub to the meter, be very careful that they go in just right, because if you cross thread them, you're gonna have a hard time getting them out and redoing it. I just like to start them by hand here. Like I said, there should be no resistance of them going in. So make sure you only get one shot at this, not to screw it up. So there you go. I usually leave them just hand tightened, or just not super tight, until I get all 4 screws started. Then I know I don't have any issues. They should go in nice and easy. I think they're 1/4-20s. So now it's nice and tight in there. So once you get the hub on, that's where your 2-inch male adapter gets attached to the meter. And then you sleeve your PVC into the male adapter, and that's how you make the connection at the meter. Now this is a PSE&G 200 amp 5-jaw overhead approved meter. And I say approved because JCP&L and PSE&G, they do have some differences on what they allow. From what I understand, well, I know for sure that for JCP&L I can use the meter main, and I think I saw a recent video where I put the meter main in. But this one here, I don't believe PSE&G has approved that. Although I'm hearing things that it's okay to do that now. I'm not 100% certain. I will have to get back to you on that. And I have a meeting coming up soon on a project I'm doing in Westfield on a new mast service, and I will ask the PSE&G inspector while I'm working on another job. This is a service disconnect. It's rated for service work. It's a 200 amp disconnect. On, off, on, off. Good for 200 amps, but this number right here, 25K, what that means is 25,000 available interrupt current. I'm sorry, this is the short circuit current rating, this 25K right here, whereas the transformer out at the street provides 10,000 available interrupt current. So as long as this number is higher than the available interrupt current from the service, then everything will be safe and there'll be no issues. If this number is lower than your available interrupt current, then that available interrupt current could essentially blow up this circuit breaker inside the house. So, not so much in residential do I run into that, but if you run into some commercial services, most electrical inspectors or building inspectors will require that you prove to them you know what the short circuit current rating and the available interrupt current is before they issue a permit. Okay, so now I've prepped the meter and I'm going to attach it to the house, and obviously I just want to go over the cutout from the old meter enclosure that was there. I did some duct seal over that existing hole where the meter fed into the back of the electrical panel of the first installation. I'm always trying out new magnetic bits to drive fasteners like I am here, but here I just have a 2-inch bit with a number 2 Phillips, which is what I enjoy using, and that's why I was struggling to get the screws in. So here I have my 6-inch extension, and as you can see, there's plenty of room for my impact driver to be on the outside of that enclosure without interfering with me installing the screws to the house. It's definitely a hobby of mine of trying new stuff for my drill. New tool belt setups. I'm always changing. I find out things that I like. I want to improve upon them. So I'm always trying new things as far as tools and ways to get work done. What I'm doing here now is I've discovered that I can't come into the back of the disconnect into the back of the panel because it'll just be too high. So I wound up putting a 2-inch KO seal in there, as you can see, right beneath the breaker on that side of the enclosure here. And I'm going to come out of the bottom, straight out of the bottom. I guess I could have used a offset male adapter there. I didn't think it was that necessary, and I didn't have one. But I'm just reviewing this video now thinking I probably could have used a male adapter. Anyhow, I'm going to go straight down with a 2-inch male adapter out of the bottom, and I'm going to attach this LB before gluing it so I can get a nice area for where I need to make my hole so that I could come into the back of the panel inside the garage. And so I just take a big thick Sharpie here and draw it, and then I'll take the LB out of there, and I'm going to make a 2 3/4 inch hole using a 2 3/4 inch hole saw. I should have definitely used my M18 drill rather than the M12. The M12 was getting heated real quick, and I couldn't get through this hole. I couldn't make the hole fast quickly with the M12. It eventually got through, but the M18's much more worthy of this job. Okay, so you saw what I just did right there. So I originally wanted to come out of the back of the service disconnect right here, okay, and into the back of the panel, but that just wasn't going to happen. There's not enough room inside the enclosure of the panel to come in on the side. I mean, I've done that before, but it's tight, it's not easy to do, and this was a better way and a more efficient way. So we plugged this in with the KO seal already, and then we came out of the bottom with an LB, and then we bored out the hole for the conduit to fit into there. And now we're down low here with this conduit coming through the wall. We're going to put this plywood over the PVC right here, and then we're going to come into the bottom corner of our panel right there. And that's how this service will live for the next 60 years. Any questions? Okay, so this is the service disconnect on the exterior, and what I'm doing is I am attaching my main bonding jumper, which in this case are these two copper straps, and what it does is it bonds between the enclosure and the grounded neutral coming from the utility. The 3-wire that comes down from the service head, one of those wires is uninsulated. That's the grounded leg, and it's also connected to ground back at the transformer, and it's center tapped at this transformer. It brings the ground to the system, and this is where we connect our grounding electrodes, and we bond this case to the grounded neutral lug, and that's what these two little jumpers are doing here once I attach them to this neutral bar. Prepping the panel here to make sure that the surface mounted 200 amp main breaker panel here is actually centered on my mounting board. This definitely goes a long way into doing a nice quality job as far as I'm concerned. Okay, so I just put the board up after doing the hole saw to get into place, see what it looks like. Looks good. It's gonna look beautiful when it's done. Trouble is, there's just a little bit of space behind this board because of this sill plate here on top of the foundation. Limited there. So fortunately I keep some spare plywood on here, and I'm going to rip a couple pieces, and I think that's going to do the trick. Let's do it. I'm always excited when I can use my circular saw on a job. So I have a few of these M18 circular saws, but this one is an M18 from probably 5 or 6 years ago with a 6.5 inch blade on it. Okay, so I didn't know it, but the camera shut down because it was too hot. It's a hot day today. It's upper 90s today. It's a cool breeze, and I'm in the shade here in the garage, but we're still working. So we're able to attach this, as you can see. Put on my light here. See how it just comes in from the back there. Alrighty, so we padded this out with some plywood. You can tell this thing's in there really, really solid. And it's centered right on the board. And so we're going to finish wiring it up, and then we can do the outside. I'm going to finish inside first, then go outside, wire it up. If you're planning on putting a 200 amp service in your house, make sure when you go to get the 200 amp main breaker panel, you actually get a minimum 40 circuits. This particular panel is rated for 40 full circuit breakers and up to 40 twin circuit breakers. So the maximum amount of power I can get out of this panel is actually 80 circuits, which is way more than you'll ever need inside this house. But with electrical demand for electric vehicles and whatever else is in our future, getting a 200 amp service is going to allow you enough power, at least for the next 20 years, I guess. I know I'm doing getting some quotes now, putting out some quotes for 400 amp services, which is really crazy in a small residential house. But if you've got 4 zones of air conditioning and 2 electric vehicle chargers, you'll need a 400 amp service without question. And a 400 amp service is actually 320 amps continuous. That's the meter that JCP&L and PSE&G will require for a 400 amp service. And at that point, you're talking about parallel conductors on your riser from the meter up to the service entrance and then into your panel. So there's a lot of planning that goes on in that. But if you were just going to be doing a 200 amp service, make sure you get a minimum of 40 circuits. I cringe when I work inside a new house less than 5 years old, and they have a 200 amp service, but the contractor put in a 20 circuit panel. To me, that's not good value. Unfortunately, a lot of new residential, not the guys are making shortcuts, but you tell me if a 20 circuit 200 amp panel is a good value or a 40 circuit panel is a better value. I think you understand where I'm going with this. So I appreciate when I see at least a 40 circuit minimum 200 amp main breaker panel, but the new builders got to do what they got to do to win the bid, and that's why you see those 20 circuit panels. Okay, so here I am doing the grounding electrode to the copper water main. The copper water main is buried in the earth, therefore it's grounded in the earth, right? The earth, as Mike Holt always says, the earth does not come with terminals to terminate your conductors. So stuff that's buried in the earth, we connect to that. In this case, it's the copper water pipe in the earth. We're gonna come down the wall over here with number 2 aluminum, which is the size grounding electric conductor dictated by the code for a 200 amp residential service like I'm putting in now. It's table 250 tax 66 is where we find the size for a grounding electroconductor. If we look at the size of the largest ungrounded conductor or equivalent area for parallel conductors, we know for a 200 amp service we're using 4/0 aluminum or 2/0 copper. So as we see for copper, 2/0 or 3/0, the size grounding electroconductor for a 200 amp service is number 4 copper or number 2 aluminum.
Now, the aluminum, if you were doing a 100 amp service, most guys, they run number 6 copper or number 4 aluminum for 100 amps. But the code says you only need to run a number 8 wire for grounding electroconductors, 8 copper. Trouble with that is if it's 8 copper, it's too small and it's subject to physical damage. That's what the code tells us. So like myself and a lot of other electricians do, we'll carry number 6 with us. That doesn't need to be protected, and neither does this number 2 aluminum, so that's why we're installing it. The other reason why we keep it on the truck, the number 6 copper is the maximum size, no matter what size service I'm putting in, grounding electroconductor to our ground rods. So number 6 is a very common size wire. We also use a lot of number 6 for the electric vehicle circuits. So I keep a lot of number 6 in stock now.
So this is like a split level house without a basement. It has a crawl space underneath the first floor. So the water main here is right inside the garage. And so what I'm doing is I'm drilling down as close as I can to that window frame because I know I have a king stud that I can attach my coarse screws and attach my straps to the wall in a workmanlike manner. So here I am going over the garage door with the number 2 aluminum for our water main grounding electroconductor. Okay, so the camera battery died. Wasn't hot this time, it was the battery. I came through with my grounding electroconductor here. As you saw, we were connecting it over at the water main. I still got to make that connection. We're just going to go inside the main disconnect that's right here on the outside. And then on the inside, it's going to be a 4-wire system. 2 hots, a neutral, and a ground to meet the code. The reason why we run 4 wires and not a 3-wire into our main lug only panel is because we want to have a separate conductor just for our equipment grounding. And the reason why we do that is because we do not want a parallel path, which means more than one path for current to flow when trying to clear a fault. If we had 2 paths for the fault current to flow, it would actually take twice as long to get back to the source to facilitate the overcurrent protective device, the circuit breaker. So if we have just one isolated path for the fault current, the ground fault current, we're able to clear the fault faster with one path rather than 2. The other path, of course, is our grounded neutral conductor, which should not be confused with the equipment grounding conductor. They're 2 different functions. The main difference between the grounded neutral conductor and the equipment grounding conductor is the grounded neutral conductor is a current carrying conductor. The equipment grounding conductor only carries current in a fault condition. So here, this is, I believe, my ground rod, number 6 auger to each of my ground rods. And what I want to do is I want to put it into this device I'm using for the bonding bridge that's attached right to the main disconnect there. I want to strip away some of the insulation so that when I make the connection to this device, it actually makes a solid bonding connection. There's a set screw, and I'm going to tighten it down and get a nice bond at the connector right there. I don't know if this is necessary. It probably is, so that's why I do it. So now there's a connection on the ground bar here, okay? The bonding bridge, we call it. And this is where you would attach all the grounding electrodes from maybe your phone system or your internet service provider or a satellite dish. All of those things are subject to faults. I shouldn't say faults, to lightning strikes. When lightning strikes, it induces a voltage, and what we want to do is we want to channel that voltage, that induced voltage, right to ground before it goes inside your house. So auxiliary grounding conductors to each of our devices, and then to a common grounding system here that I'm installing, facilitates that. This is the main breaker panel. This is the main breaker rather, and those are my main disconnect. And so all my grounding electrical conductors and my grounded neutral conductors all meet here, and this is where they're bonded together, where any kind of ground fault from the equipment grounding conductor will actually go back on the grounded neutral, back to the service in one quick path. Let me know in the comments you got more questions about that. Not an easy subject to discuss and have somebody understand for sure. But I do spend a lot of time in the classroom as a licensed electrician. There's 34 hours every 3 years of class time instruction, continuing education that's required in order to update my electrical license every 3 years here in New Jersey. In some other states around the country, it's different. It might be 2 years. I think actually the registered journeyman now in New Jersey, every 2 years, they got to do 15 hours of continuing education. I am a big fan of the continuing education because the electrical trade is evolving constantly. We know a lot more than we did, say, 50 years ago about electrical current. And I believe the rules here in New Jersey serves not only the electrician well, but our customers as well, because we have the knowledge to make proper installations and make your house safe. And this is why you should always choose a licensed electrical contractor. You're really taking a chance by hiring anybody to do your electrical work that's not licensed. That's a big chance. And if something bad were to happen to your house, the person that installed it would not be on the hook. You would be on the hook because the person installed it is not insured. So here I'm driving some ground rods with the SDS Max M18 tool. It definitely makes driving ground rods very quick. And then this is probably the worst part of the job that I don't like, is getting in here in the dirt and moving away the mulch and burying the grounding electrical conductor to each of my 2 ground rods. This was a very, very hot day. Unfortunately, I'm in the shade here at the end of the last part of the day, and I'm just sweating like mad. And the dirt and the sweat just makes you aggravated. At least it makes me aggravated. I'm sure nobody likes that. And so, but it's got to get done for safety, and it did get done. So here, if I could do this all over again, I'm actually gluing. When I first got to the job in the morning, you'll see that piece in my left hand, the bent piece there. I got no power, so the first thing I do when I get there is I get the PVC heater out and I make the bend that I need to do this service riser ahead of doing the service riser. But what I did was I glued it together and then tried to carry this giant piece up the ladder, and that was a mistake. I should have just put a straight piece in the top of the meter here and then gone up top and measured where the end of my bent piece of PVC ended up and then made my cut. I try to make my straps on my riser here equal distance apart, while also, as you can see from the old service, you have some discoloration on the aluminum siding. This isn't vinyl, this is aluminum siding on this house. So what we want to do is we want to try to cover up the old holes with the new strap, so it looks nice and neat. That's what I'm trying to do here.
With younger bands, it's different because you're being turned on to them with their.
This was a very high riser. It's actually about 25 feet of 2-inch PVC and the copper conductors here. And I'm way up at the top there. I need a new extension ladder, and I'm at the top of this ladder. It was kind of dangerous what I was doing here, so don't do this at home if you're not trained. And I just actually ordered the new ladder. I got to go pick it up next week. Anyhow, so here I am on the ground, just pushing up the individual service entrance conductors up to the service head, or to the weather head, I should say. And then, unfortunately, I did not record the cameras. It was so hot this day. It was just too hot, and I had to get this work done. So I went up, and I tied in, and I actually got a little buzz while I was up there tying in. I had my uninsulated T-handle to tighten down the butt splice, and my arm, my elbow on my left hand was actually rubbing up against the aluminum siding, so I got a little bit of a tinge, which was kind of a scary moment on top of the extension ladder, like you see. Maybe I should get some gloves. I see that in the comments section a lot. I used to have them. I got them from a utility company worker many years ago, and I could have sworn they're somewhere in my garage. I know they're in my garage someplace. I've looked for them a couple times. I haven't been able to find them, so I hope I didn't accidentally throw those away. But you might see me with new gloves coming up soon, especially here with the aluminum siding. Obviously, that aluminum will conduct electricity, and it is connected to ground with this equipment right here. Hey guys, so I'm back here the next day on Tuesday. Finished up last night. I pulled out of here around 6:30, 7 o'clock-ish. I had a couple
loose ends to tighten this morning. I did that, and I just wanted to show you the final result of the electrical panel. First, let me show you over here the grounding electrode for the water main, which is here. So the idea is that you hit this first point, the code tells me within the first 5 feet of where it enters the house. Obviously right by where my right foot is where it enters. Okay, that was the previous ground clamp there for the 100 amp service that was here. This is the number 2 aluminum, and it jumps from the one side to the other side, even though the meter I think is outside, so I'm not sure we really need to do that jump, but we did it anyway. What I'm talking about is the jump from here to here. It looks like the water main used to be in here, but it's not anymore. But anyway, if they decide to put that water main in, then the jump will be there. So that's why we left the jump as it was. And I left the old clamps on there down here. Sometimes when you take those off, you unsettle the copper water pipe, and now all of a sudden it's dripping, it's leaking, and you're thinking, well, what am I going to do? I'm not a plumber. I don't know how to stop a leak. So if I can avoid touching it at all costs, that's what I'm going to do, to avoid any further interruptions, or any interruptions I should say, on that water main. So that's why I left it in place and just cut off the old grounding electrical conductor. Here is my new 40 circuit with the capacity for 80 circuits with twin breakers, the new Cutler Hammer BR panel. We have obviously the whole house surge protection right here. We have a 200 amp main breaker. We have double pole circuits for the 3 wires. This is also a 3-wire circuit here. I just had to extend them. Up here in the panel, I had to put in a few Wagos. Could have used wire nuts, decided to do the Wagos a little faster yesterday to get this done. Like I said, I didn't leave until like well after 6:30 last night, or 6 o'clock I should say, probably closer to 7. And by the time I got home to eat dinner, it was close to 8 o'clock. So it was a long day. So today what we're gonna do is we're gonna label each of these circuit breakers on the legend that's inside here as required by the code. And we also got to put in an exhaust fan today in the bathroom and change out about 15 duplex receptacles. Out here to finish the tour of the electric service, we have our 200 amp meter, which is here. All right, the line side is always on the top, the load side is always on the bottom. We have our main disconnect right here, so the power comes in from up at the service point up there, okay, and then down this riser conduit into the meter. So everything that's being used is metered, obviously. The load side comes over to here to the line side of our service entrance main disconnect, okay, and then the load side of that disconnect is what goes down and into the panel through this LB fitting. Now I haven't done it yet, but I'm going to fill this conduit fitting with some duct seal so that the warm weather doesn't meet the cold weather in the winter time. We also drove a couple ground rods down here, and we'll put our other ground rod over here. And that about wraps up this service upgrade pending a final electrical inspection. If you like this video, do me a favor, hit that like button, and we'll see you on the next one. Thanks, guys. Thanks for watching this video. Be sure to subscribe, and we'll see you on the next one.